Have you ever looked up at a giant skyscraper and just wondered, how does that thing stay up? Or how does clean water get to your faucet? It can feel a little like magic, but it's not. It's civil engineering, and it is the invisible art that literally shapes the world around us. So let's pull back the curtain and see how it's all done. Seriously, just think about your day so far. The road you drove on, the bridge you crossed, maybe the subway you rode. None of that happened by accident. It's all part of a massive, carefully designed system. It's a testament to incredible planning. You're not just in a city, you're inside a masterpiece of engineering. Okay, so how do they actually do it? How do engineers create these massive structures that seem to just laugh in the face of physics? Well, it all starts with tackling one fundamental and totally relentless force: gravity. Now, this might look super simple, right? Tension poles, compression squeezes, but this is the secret to pretty much everything. Every single structure you see is in a constant tug of war. Tension is trying to rip it apart, and compression is trying to crush it. An engineer's job, it's to be the ultimate referee in that epic battle. And this is how they win that battle. This is the engineer's secret weapon. See, steel is absolutely amazing at resisting being pulled apart. That's tension. Meanwhile, concrete is a total rock star when it comes to being squeezed. That's compression. So what do? You put them together. By embedding steel rebar inside concrete, you create this super material that's stronger than the sum of its parts. It's the perfect team up to win the war against gravity. All right, so we've got a handle on gravity, but what about another one of nature's most powerful forces? Water. Getting clean, safe water to millions of people is a huge challenge, and believe me, that water goes on quite a journey. You know, a lot of our fresh water isn't in lakes or rivers. It's hidden deep underground in these things called aquifers. Just picture these giant, natural underground sponges made of rock and sand, holding incredible amounts of water. The very first step is just getting to it. Okay, once we have the raw water, it's time to clean it up. First things first, we screen out all the big stuff, leaves, sticks, things like that. Then the water gets to chill out in a quiet tank where gravity does its thing and pulls all the gunk and silt to the bottom. And finally, we disinfect it to zap any nasty bacteria. And voila, it's safe and ready for your glass. So we've figured out the water. But what about the very ground we're building on? I mean, you can't build a strong house on a shaky foundation, right? The same goes for our cities. Mastering the earth itself is always the first real test. And this is where engineers kind of have to become geologists. They know you can't just use any old roller for any old dirt. Different types of soil, sand, clay, gravel, they all need different tools. It takes exactly the right equipment to compact the ground and create that solid, unshakable base our world is built on. Okay, with a solid foundation beneath us, we can start connecting everything. And you might not realize it, but every time you get behind the wheel, you're taking part in a giant physics experiment that's designed to keep you safe. So here is where it gets really interesting. When you take a curve in your car wants to keep going straight, right? That outward push is called centrifugal force. And here's the kicker. If you double your speed, you don't just double the force pushing you outward, you actually quadruple it. It grows exponentially. That's a pretty powerful reason for those speed limit signs, huh? And that's exactly why you see banked curves on highways. It's not just for looks. It's a very carefully calculated angle that uses the force of gravity to help counteract that outward push and keep you on the road. It's pure physics, all designed to keep you safe, one curve at a time. All right, we've seen the science behind the buildings, the water systems, and the roads, but how do you actually bring all of this together? How do you coordinate a project as complex as building an entire city district? Well, that's where the ultimate blueprint comes in: project management. In the world of massive construction projects, time really is money. And sometimes it actually makes sense to spend more money to finish a project faster. There's a term for this. It's called crashing a project. And yeah, it sounds intense because it's a very calculated risk. Okay, so let's put some numbers on this. Imagine you're building a new bridge. To speed things up, you pay your workers overtime, you get materials delivered express. All of that might cost you an extra $2 million. That's a lot of money. But, and this is a big but, here's the other side of that coin. Every single day the project runs, you're paying for stuff like site security, equipment rentals, all that overhead. By finishing early, you save all of those costs. In this case, maybe you save $2.5 million. You see,
It's this high-stakes balancing act. You spend $2 million to save $2.5 million, and you actually come out $500,000 ahead. So crashing a project isn't just about going fast. It's about being incredibly smart with your money.
You know, there's this quote from way back in the 19th century that just nails it. It perfectly captures the whole spirit of civil engineering. It's not just about building stuff. It's about understanding the forces of nature and working with them to build a better, safer, more convenient world for all of us. The world we live in is this incredible legacy of human ingenuity, but our work is far, far from over. With new challenges always on the horizon, climate change, growing populations, the next generation of engineers will have to dream even bigger and build even smarter. So the real question is, what will they create? The next chapter is waiting to be built.